Children, in our last video, we started with the lesson acid and base, and in acid, we have seen the main constituent is H plus ion, and in base, the main constituent is OH minus ion. Now, let us begin with the next topic, that is indicators. Now, as I told you, for checking any substance, we directly cannot taste that substance. It might be dangerous, and for that purpose, the substances which are neither acidic nor basic and are chemically inert in nature are used, and those are indicators. Touching or tasting of acid or base can be very harmful. So, a typical indicator can be used to recognize these substances. The substance which change their color in presence of acid or base are called as indicators. So, these substances are used to check whether the compound is acidic or basic. Now, there are different types of indicators: natural indicators, and in laboratory, the indicators are also used. Now, in natural indicators, the indicators that are obtained from plants are known as natural indicators. For example, turmeric, then red cabbage, hibiscus flower or your shoe flower, and uh, and beetroot. So natural indicators can be prepared by using these ingredients, that is red cabbage, radish, tomato, or turmeric. So these are the natural indicators. Whereas the indicators which are used in laboratory are methyl orange, phenolphthalein, and litmus paper. So, in the laboratory, litmus paper is mainly used to test alkali or base. This paper is made by an extract of lichen plant. It is red or blue colored. Blue litmus paper turns red on dipping in acid, and red litmus paper turns blue by alkali. Similarly, phenolphthalein, methyl orange, and methyl red are used in laboratory in solution form. Methyl orange indicator becomes pink in acid and yellow in alkali. See children, methyl orange indicator becomes pink or slightly reddish in color in acid and yellow in alkali, whereas phenolphthalein remains colorless in acid and becomes pink when dipped in a or when put in an alkali. See this litmus paper. Litmus paper turns red when dipped in an acidic solution, and litmus paper turns blue. It is pink and it turns blue when dipped in an alkaline solution. Now children, in your textbook on page number 84, the table is given, that is indicators and their color in acid and base. Let us check this. Now name of the indicator, that is litmus paper, blue litmus paper. When blue litmus paper is dipped in an acid, it changes to red, and when it is dipped in an alkali solution, it remains same, that is blue. Then litmus paper red. So red litmus paper, when it is dipped in an acid, it remains same, that is no change in color. Whereas when it is dipped in alkali solution, the red litmus paper turns to blue or changes to blue color. Now methyl orange. Methyl orange, color of the indicator. When methyl orange is added to drops of methyl orange are added to an acid, it changes to pink, and when it is added to an alkali, it changes to yellow color, as just I have shown you the solution before. Now phenolphthalein. Phenolphthalein, color of the indicator is colorless. So when it is added to an acid, it is same, means colorless only, and when it is added to an alkali, it changes to pink color. Then methyl red. Red in color. When it is added to an acid, it remains red, and when it is added to an alkali, it changes to yellow color. See this. Just now the images which I shown you is mentioned in the table here. So methyl orange, when it is added to an acid, it changes to pink color. When it is added to an alkali, it changes to yellow in color. Then is your methyl red. When methyl red, it is added to an acid, it remains red, and when it is added to an alkali, it changes to yellow. Then is your phenolphthalein. As it is colorless solution, and when it is added to an acid, it is colorless. Yes, and when it is added to a base, alkali, it changes to pink in color. Now children, in our textbook on page number 84, one activity is given. That is, try this. In this try this, we have to prepare indicator paper. So here it is given apparatus, that is hibiscus, rose, turmeric, red cabbage leaves, filter paper. Any of the one you can take. So here I am showing you litmus paper, how indicator paper has been made, but here I am showing you with red cabbage leaves. See here what they have done. They have taken a red cabbage and cut into small pieces. Then those small pieces are grinded. That paste or that liquid is being taken. Yes, that liquid is strained. Liquid is taken, and in that liquid, your filter paper, the filter paper which we are using in the laboratory, small strips are being cut of that filter paper, and that filter paper, those filter papers are dipped in this red cabbage solution, and they are allowed to dry. So this paper we can use as an indicator paper, making a red cabbage indicator. So this paper can be used as a indicator for testing different solutions. So children, in the same way turmeric paper can also can be made. Now here again one box is given, that is, put some drops of following substances on the indicator paper prepared by the above method, and you have to check the result. That is, first one is given lime juice. So lime juice, what is the effect of lime juice on turmeric paper? So it changes into yellow, it is yellow color. So that is means what? It is acidic in color, acidic in nature. Next one is lime water, that is calcium hydroxide. So effect on turmeric paper, that is it becomes red. So it is basic in nature. Now one more activity is given over here, that is, what do you observe on addition of baking soda solution in the fruit juice? Whether bubbles are formed or effervescence came out of the fruit juice. So now here they told us, similarly in addition of baking powder solution is added in the fruit juice. So what happens after this? Effervescence are produced. Can you see this? Effervescence are produced. So by this simple and easy activity, we can identify the given solution whether it is an acidic or a alkaline solution. Hope you have understood this video.